Hey folks, welcome to another episode of Rust from the Beginning. This time we'll talk variables. Okay, now we're looking at a program. It has three different variables. It's called sum, name, and isOn. Let's have a look at the different values of these variables. So first off we have 12, which is an integer. Then we have Chris, which is a string, and then we have true, which is a boolean. You can also have the value false. For our business, let's try to print these variables. So we'll decomment some code. Now we have a print line. Look here at the top, we have a type of function. Don't worry what it does. It may look complicated, but the only thing it does for us is to tell us what type does this variable have. This is a great function to use for inspecting things. To run our program next, so we head and type rustc exercise.rs and let's see what the compiler is telling us. Right, it's telling us that I'm trying to use a balance variable. That's my bad. Let's comment that back. Let's try to use balance and let's try to run this program anew. Okay, so this time it compiled without trouble and is able to print what we needed to print. Looking at it, we see that it's telling us that we have i32, integer 32-bit, we have string, we have boolean, and we have float 64. So that's great. This is a great way to inspect the types of your variables. Here was to implicitly tell our variables what type they should be, looking at the values. So 12 was inferred to be an integer. With a name it was inferred to be a string, and isOn inferred to be a boolean, and so on. But let's be explicit. Let's comment this one back. Now we're looking at let balance, and this time around it's being explicit because we are using a colon F32. We are being explicit, saying it's a float 32. And by doing this we are creating a guard as well. So let's say we assign it with a value that's clearly an integer, and let's try to compile that. When we try to compile that, the compiler will tell us, hey Chris, you're doing this wrong, you are giving it an integer, it should in fact be a float 32, I need to fix that. One way to fix that would be to add a .0. The other way would be to use an operator to fix the same thing. So let's head back, let's try the other version as float 32. That's another way of doing it, to convert it from one type to the next, and we can see that the compiler is happy with us and the program runs without a problem. Let's look at a piece of code that makes no sense. It's an algorithm. Let's try to find out what it does. What it's trying to do is to multiply a bunch of values, 2 multiplied by 3.14, multiplied by 10, and multiplied by another 10. So what we're wondering at this point is, what is this? Can we use variables to create clarity? The answer is yes, we can. If we remember the math from high school, we identify 3.14 as being pi. What we want to do next is to create that variable with the let keyword. Pi equals 3.14. Once we do that, we want to replace that static value in the print line with our variable. Next, we're looking at 10, which is our radius. So we assign it with 10, and again, let's replace that static value with a name for a variable instead. Now we already have clarity. This might not work, but let's try to compile it. Our compiler is telling us, hey Chris, you're doing this wrong again. You are mixing integers and floats. You need to fix it. We've seen before how we can fix it. A way to do that is to just add zeros at the end. We need to make sure that everything now is a float. So it's 2.0, 10.0, and now we try to compile things and things work out. One more piece of clarity here. What we can add is an area variable that will tell us, look, we're trying to do a calculation here. The end result is an area. So we added pi, we added radius. Now we're adding an area just to say, to provide that complete clarity of what we're trying to do. So at this point, we're just adding all the different bits that we had in the print line, and we're going to replace all of that with our area variable. And that's great. Let's try to run this, make sure everything works out fine. And look at the end result. You have complete clarity. You started with a bunch of static data that didn't make much sense. Now, thanks to all the variables, you have that clarity you need. one more thing today, and that is to try to change a variable. So let's try to take radius, assign it with a new variable, and see what happens. First off, the compiler is going to tell us, hey Chris, this is a float, you can't just give it an integer. My bad, I fixed that, and let's see what the compiler is telling us this time around. This time is telling us, this variable is immutable. You can't change immutable variables. And this is something that Rust does. It binds variables, it binds values to variables. If we want to change it, there are two ways. The first way I'm going to show you, you use the mute keyword, mute for mutable, and now you're signaling to the compiler that this change is actually okay to do. So we compile this again. Let's try to run the program, and yes, now we have a new value, new end result for our area. Let's try the other way around, and let's this time create a shadowing. So we are hiding essentially the old reference to radius by this new value to radius, so that radius on line 9 is out of scope the moment that you declare a new variable with the exact same name. So this is another technique that you could be using to just say, hey, I want to change this variable value. Now you can see that everything works out fine and you're able to change it even with the second way of doing things. That was it, folks. That's all I had today. You were shown how you could be declaring and assigning values to different variables. You were also shown how to change these values on variables. You were also shown how you could work with types.